Hey folks, this is going to be a video on section 7.1. The intent is to split this into two separate videos. First, let's just talk about what identity means. An identity is simply an equation that's going to be satisfied by every single value in the domain. It doesn't matter what you decide to plug in this case, we're going to be using thetas. It doesn't matter what you plug in for theta. It's always going to be true no matter what you plug in. So that's what an identity is. It's simply a statement that's always true. You can bank on it. You can count on it. It's always going to be a true statement. Some of these identities we've already done back in chapters 5 and 6. So a lot of this is just simply going to be review. The three reciprocal identities that we're going to be working with, first of all, is cotangent theta. We know that cotangent is the reciprocal of tangent. Whenever you see 1 over something, in English, you can read that as the reciprocal of. So when I say that cotangent is the reciprocal of tangent, that's the same thing as cotangent is equal to 1 over tangent. A secant of theta is going to be the reciprocal of cosine theta, and cosecant is going to be the reciprocal of sine theta. Quotient identities are where a specific trig function is equal to a fraction, is equal to a quotient. So we know that tangent of theta is equal to sine theta divided by cosine theta. And we know that cotangent, I'm going to just slide this a little bit, cotangent of theta, we know that tangent and cotangent are reciprocals of each other, so it's not a surprise that cotangent of theta is equal to cosine theta divided by sine theta. And then we have our three Pythagorean identities. The Pythagorean identities look a whole lot like the Pythagorean theorem. And so the first one is going to be sine squared theta plus cosine squared theta is equal to 1. And the second one is tangent squared theta plus 1 is equal to secant squared theta. I will say on this one that frequently I don't write it necessarily in this order. I write it as 1 plus tangent squared theta is equal to secant squared theta. Obviously, that's the exact same thing, but just so that you know how you might see it. And then the last one is 1 plus cotangent squared is equal to cosecant squared. Now, when I'm in the classroom, I share a stupid little phrase that helps students to remember the second two Pythagorean identities. And so I'll share that here with you as well, but let me tell you, it really is a stupid phrase. But I was always forgetting, is it tangents that goes with secants, or do tangents go with cotangent? I just couldn't remember the Pythagorean identities, so this helped me to remember. So this first one I have is, I'm going to use a sentence that will help remember. So I have 1 truck. So I use truck because it starts with T and so does tangent. So 1 truck is sensational. And so it's kind of a dumb statement, but if I can remember that sentence, then I can easily remember what the Pythagorean identity is in this case. The second one was a little bit more challenging because I couldn't just use 2 C words because both of these start with a C. So this one is even more ridiculous, but it will get a statement in your head, and you probably will not forget this. So this one is going to be 1 cot is cascading down the mountain. 1 cot is cascading down the mountain. Stupid, I know, but if it helps you to remember, then that's all that really matters. All right, now you need to understand that with these Pythagorean identities, there are going to be alternative Pythagorean identities that you need to recognize and that you can also use. So you'll notice here that they've taken the original Pythagorean identity and they isolated the sine squared by subtracting cosine squared on both sides. So this is a manipulation of this identity. It's the same identity. It's just simply a manipulation. It's a reworking, a revamping of the same identity. Same thing with this one, where you have cosine squared is isolated. This particular reflection question asks you to write some alternative forms for the other reciprocal identities, and you can do that. I will mention that occasionally, this is not This does not occur often, but it actually does occur, I believe, later on in this set of notes. They will not only will they isolate a sine squared, but they may isolate sine as a whole, any of these that have squares on them, by taking the square root of both sides. Of course, remember, whenever you take the square root of both sides, you have to remember the plus or minus option here. So a plain old sine is going to equal a pos or neg square root of 1 minus cosine squared theta. Now, one mistake that students commonly make is they want to try to take the square root of each little piece, and that's illegal when it comes to adding and subtracting. All right, let's look at example 1. And this will be, example 1 will be the end of this particular video. So example number 1 says that we're told that cosine is equal to 5/8. Now you want to be thinking here, cosine, according to SOHCAHTOA, is adjacent over hypotenuse, SOHCAHTOA. And you're also told that theta is in quadrant 4. So the very first thing, when we are given this information, we want to go ahead and draw a picture. So you can see actually probably on screen that I've already got a picture drawn. But we know what our adjacent side is. Whoops, that's ugly. We know what our adjacent side is. It's 5. And we know that our hypotenuse is 8. And so then we just simply have to find the missing side. So we're going to do some a Pythagorean theorem here to be able to figure out what that missing side is. So 8 squared minus 5 squared is going to give me my missing y value squared, which is going to be the square root of 39. Remember, though, that this is going down, so it needs to be a negative square root of 39. So don't forget about that. That's pretty important. Okay, so now we can use our picture to find each of these trig values that we're being asked for. So the first one that we're being asked for is the sine of theta. So for, again, using SOHCAHTOA, SOHCAHTOA is opposite divided by hypotenuse. So it'll be negative root 39 over 8. Tangent is going to be opposite over adjacent. SOHCAHTOA, opposite over adjacent. So that's going to be negative root 39 over 5. Now, part C is a little different. So let's camp out here for just a moment. This is, we're looking here at negative theta. All right, so if we understand that when we drew our picture, this was a picture of our theta. And the way that we got there was to go all the way around to the 4th quadrant to get that value. Well, negative theta then, let me change my color so that it's not confusing. Negative theta then says that we're going to go the exact same distance in the opposite direction. So that's going to go something like this. And so I'll have a picture that looks something like this, where my hypotenuse is still 8, my adjacent is still 5, but now my opposite is positive square root of 39 because it's going up. So it's a mirror image of the original triangle that we had. We want the secant of this value. We know that secant is the reciprocal of cosine. Cosine was 5 over 8, so the reciprocal here is just simply going to be 8 over 5. All right, so I'm going to wrap up this particular video at this point and stay tuned for part 2 for section 7.1.